I'm not doing good with the recording today. I thought I hit it like 5 times. F of x equals x cubed minus 5. What's the derivative of the inverse function at 3? I'm going to do it 2 ways. Option 1, I'm going to find the inverse. So here's my question. Y equals x cubed minus 5. How do you find the inverse? You interchange x and y and solve it for y. And to solve this for y, you raise it to what power? Not negative, positive 1/3, right? Because power to power you multiply. What's 3 times 1/3? 1. So what's y equal to? X plus 5 to the 1/3. That's your inverse function. That's your f negative 1.
Just double checking, that can also be written as the cubed root, correct?
Correct. It is the cube root, yes. But now you want to take the derivative of that. So how do you take the derivative? The general power rule, right? So it'd be 1/3 times what's inside the parentheses to what power? Negative 2/3. 1/3 minus 1 is negative 2/3. You subtract 1 from the power. Times the derivative what's on the inside, which is what? 1. So when you clean it, that's 1 over 3 times x plus 5 to what power? 2/3. And the last question, they want the derivative of the inverse at 3. You let x be 3, what do we have? 1 over 3 times 8 to the power of 2/3. Now, in case you forgot what 8 to the 2/3 means, that's the cube root of 8, the whole thing squared. The cube root of 8 squared. What's the cube root of 8? 2 squared. 4 times 3? Is it 112? That's option 1. Is you find the inverse, then you take the derivative of it. I like it because it makes sense. Sometimes find the inverse not that easy. So what section actually 3.6 is, you don't have to go through that. The equation section 3.6, that's option 2 now. I'm going to look at it. G is actually the inverse of f. They're using the letter G for the inverse of f here. It says if you want to find the derivative of g sub x, that's the inverse of f. That's what g is. G is f to the minus 1, or the inverse of f. You can find that by taking 1 over the derivative f at g sub x. Let's see how that works. This is option 2 now, using this method. F of x equals x cubed minus 5. And they want the derivative at 3. What you want to do now, you let f of x be 3 here. This method said, because you're going to plug it right here, g sub x. You need to find what that value is. Let f of x equals 3 and solve it for x. Bring the minus 5 here. 8 equals x cubed. What is x equal to? Isn't that the cube root of 8? which is what? 2. So now if you want to find the answer to this, that question, it is actually 1 over f prime at 2. 1 over f prime at 2. So what's f prime here? F prime of this function, what's the derivative x cubed? 3x squared minus, what's the derivative 5? 0, that's 3x squared. So what is the derivative at 2? 3 times the derivative at 2, let's see. 2 squared is what? 4. I already have the 3 already here. Let me take the 3 out. 4 times 3, 12. So what's the derivative at 2? That's 12, and the answer is the same. Is it 112? I don't have to find the derivative of the inverse function. I don't have to find the inverse function. It says find, if they say find the derivative of the inverse at 3, find the x value that has f of x equals to 3. Go through it, find what that number is, then go 1 over the derivative of the f function, this one, at the 2 in this case. So that was number 1. Just 2 different ways of doing it. They're looking for this method because that's quicker. But I just did it both ways just to show you the answer is really the same. Because people see that like, what is that? So that's number 1. Next one on the list is number 5. Oh, another one just like this one. So you get to see them twice. Number 5. F of x equals x plus 3 over x minus 5. They're saying x is greater than 5. And they want it at 3. What is the derivative of the inverse function at 3? Again, they picked 3 again. So the first step, I need to find out what value of x will have a y value equal to 3. So 3 equals x plus 3 over x minus 5. And let's solve that one. To solve it, I'm going to get rid of the fraction by multiplying by x minus 5. Three x minus 15 equals what? X plus 3. All the x's on one side, all the numbers on the opposite side. 2x equals what? Is it 18? X will have to be 9. Sure. There's a jar I have right there. Help yourself.
Oh, yeah, you're the best.
That's a shotgun. There's paper and everything.
All right, thanks a lot.
No problem. That's Professor Magala if you take him for, is it econ or something? Economics?
Yeah.
He looks like a good guy, cool guy. No? You did? Yeah. So x equals to 9. So now to find the derivative of the inverse function at 3 is going to be 1 over f prime at 9. So let me take the derivative of this. Here we go. Well, we better find the derivative of that. So what method? So this is f of x. What's the derivative of that? What is the derivative of x plus 3 over x minus 5? Because that says take the derivative of that. What method we're going to use here? Quotient rule, yep. F is always the top. G is always the bottom. Derivative f is 1. Derivative g is also 1. The quotient rule says what? It's g times f prime minus f times g sub prime over g squared. That's your quotient rule. Plug them in. X minus 5 times f prime, which is 1, minus f, which is x plus 3, times g sub prime, which is also 1, all divided by what? X minus 5 squared. And what are we going to have? Is it negative 8? So that's your f prime of x. That's the derivative of this function. Now I need that derivative at 9. What's the derivative at 9? It's going to be negative 8 over, what's 9 minus 5? 4 squared, 16. So what's that number? Negative a half? Once you have that, come back right here now. I'll put an arrow so when you go home, so what happened here? Come back from here, back to this one, and it's going to equal 1 over negative 1/2. And what's the answer? Is that negative 2? So that's how we find the derivative of the inverse. I don't want to find the inverse. It won't be pretty finding the inverse here. Even if I try, it's going to be ugly. That's a quicker way. You might say, that's quick? Trust me, that's a lot quicker than if you were finding the inverse first, then taking the derivative. Next one. Now we're going to the good stuff. The derivative of arc, well, dy dx. So this is what we have. Arc, this is number 7. Arc sine of xy equals 2/3 arc tan of 10x. They want us to find the derivative at 1/10 comma 5. Before even I do anything, think about the derivative. I'm not a fan of fractions. So guess what? I'm going to multiply both sides of the equation by 3. I don't want to see fractions. If I can avoid them, why not? 3 times arc sine xy equals what? 2 times arc tan x. It's a better way to write it. In case you forgot, the derivative of arc sine u. Remember what that is? U sub prime over what? Square root of 1 minus u squared. Where's the book? Somewhere in it. Arc sine u sub prime over the square root of 1 minus u squared. The derivative, while we add it, of arc tan. Notice I keep writing them down because I can't really, my memory is horrible. So by writing them down all the time, they stay fresh in my mind. And now let's look at it. For the first one, u is xy. That's x times y, so I have to use the product rule. So here we go, 3 times. Let's find the answer to this. This is 1 minus, this is my u right here. Square that. You can write that x squared, y squared when you square xy. On the top, I got to take the derivative of that. What's the derivative of that? I got to use what? The product rule. The first, which is x, times the derivative of the second. Maybe I'll do y sub prime, be nicer than fraction dy dx here. Plus y times the derivative of x, which is what? 1. Let's take the derivative of that side, arc tan. Now my u for the tan is going to be what? 10x. So it's 1 plus, when you take 10x and you square it, what do you have? 100x squared. And what is the derivative of 10x? 10. So for this one, u equals 10x. For this one, u equals xy. So the derivative of that will be 10, and square that is 100x squared. The derivative of that, x times y sub prime, plus y times 1. And that's what you have in the bottom. Beautiful, huh?
It's a real masterpiece.
Well, the only, you know what's the quick way? Multiply by the square root on both sides. If you multiply by the square root, that's 3 times this, 3 times that. 2 times 10 is 20. Maybe I write this xy squared like this instead of x squared, y squared. It doesn't really matter. That's why they give us the answer at a point, just to make our life easy. Now, you're going to bring the 3y there. So when you take the 3y, it becomes a minus. And what's the last step? Divide everything by 3x. And it looks really ugly, but The good news, they gave us numbers to use. X is 1/10, Y is 5. Let's plug the numbers, and I bet you it's going to fall apart. Three times 1/10, that's 3/10, the bottom. Here's the minus. Let's look at the easy ones. 3 times 5, 15 here. Let's look at this one. X is 1/10. When you square that, what's that? 1/100th. What's 100th times 100th? 1 plus 1, 2. There's 20. 1 minus x times y. That's 1/2. Squared, that's 1/4. They want the exact answer? Okay. 20/2, which is what? 10? What is 1 minus 1/2? 1/4. Is that 3/4? Minus the 15. Ten, the square root of 3. What's the square root of 4? 2. What's my LCD here? 10. The 2 and the 10 here. I'm looking at the little fraction. This is over 1 here. So 1, 2, and 10, that's a 10. Let's multiply by 10, by 10, by 10. Jimmy, what are you yelling? Five times 10, 50. The square root of 3 minus what? 150. That's the answer I see on the computer. So I don't know if George tries all the decimal ones like these, leaves them, he goes, it takes it. So I don't know if he tried any of it. But I try to match their answers they have there, and that's the answer they got on the system. Which one is this? 7? I hope that was 7. Yep.
You could have divided the 10 by 2, right?
Can't. That's under square root. The 4 here?
Not the one below. The 10 over 10 square root of 3 over 2.
I mean, made like a 5?
Yeah.
Oh yeah, I could make that a 5. Sure. Then 5 times 10? 50. Yep. I didn't even see that. But you could, yep. We got 2 more here before we get to the last 2 sections in the book. Number 16. And we have find the equation of the tangent line. That's find the derivative. At 0, 0. They give us the point. I like that when they give us the point. We have arc 10. Is it arc 10? Yep. Arc 10 xy equals arc sine 9x plus 9y. Let's talk about the tan. The derivative of that. So for the tan, u is actually xy. The derivative of that is going to be what? X times y sub prime plus y times 1. The sine, u is going to be this piece, which is what? 9x plus 9y. What's the derivative of that? 9 plus what? What's the derivative of 9y? Yep, dy dx or y sub prime. So for the tan, the answer is what? U sub prime over 1 plus u squared. For the sine is going to be what? U sub prime over the square root of 1 minus u squared. And now fill in the blank for each one. X times y sub prime plus y over 1 plus xy squared equals 9 plus 9y squared over 1 minus. If you want to make life easy on you a little bit, I usually don't take the easy way, but if you want to take the easy way, plug in these numbers now, the 0, 0. Instead of leaving them there and plug them at the end. If you plug them now, you'll see the algebra becomes 10 times easier. So if I plug in the 0, 0 here, x is 0, 0 times the derivative, that's 0, plus 0, that's 0, right? So 0 divided by anything is what? It doesn't matter what the answer on the bottom, as long as it's not 0. So this is 0 over 1, actually, which is 0. The other one is going to be 9 plus 9y prime over the square root of 1 minus, what's that number here? That's 0, right? So what do we have here? 0 equals 9 plus 9y sub prime. Can you solve that now? Y sub prime is a minus 1. I bet you if you go back to the previous example, you plug in the numbers early, would have made the algebra a little bit easier. You can do it now. Me, I like playing with the algebra, so I would have multiplied by the LCD and collect like terms and all that. Then it gets really big. But once you take the derivative, plug in 0 for x, 0 for y. Now the derivative, 0 for x, 0 for y. Yes?
Doesn't y prime equal 0?
We don't know what y prime is.
What's that?
We don't know what y prime. We're looking for it.
So the one on the left, we didn't substitute a 0 for that one?
The one, no, here? No, we put 0 for x. 0 times anything is 0. So y sub prime at 0, 0 here as substitution. This will give you y sub prime at 0, 0, which is negative 1. And in this case, they're not asking for they actually found the derivative here, y sub prime to be negative x, then they plugged in. That's it. Oh, is that the right question? They asked for the derivative as 0, 0. So it should be a number, it shouldn't be negative x. Unless I'm seeing things today. When you ask for the derivative at a number as 0, 0, your answer does not have x in it or y, just a number. So I think they found the derivative as a function of y first, but they never plugged it in here. At least on mine.
So what's the answer?
Minus 1.
Oh, says that was wrong.
Oh, you made a mistake then. I'm sure yours is different.
Yeah, it is.
Unless we made a mistake taking the derivative, let's take a
It's
peek.
different, but it's 8x plus 8y instead of 9x plus 9y. That's the only difference.
That'd be the same.
Yep. 8x and 8y. And is 0, 0 the point?
Yeah.
Find the equation. Oh, find the equation of the tangent line, not the slope. Find the equation. This is the slope. So the slope, m, is minus 1. The slope is the derivative. So now we know m equals minus 1. We have a point 0, comma 0. How do you find the equation? Y minus y sub 1 equals m x minus x sub 1. Y minus, what is y sub 1? 0. Negative 1 times x minus 0. Y equals negative x. So if they're looking for the equation, not the slope of the tangent line, the equation of the tangent line, try the minus x, see if it's correct. Yep. Yep. So the derivative, the slope is minus 1, but they're not looking for the slope, they're looking for the equation of the line. I'm getting tired seeing things.
Just out of curiosity,
Yep.
is there a reason why slope of the tangent line isn't just like m sub tan?
Where's an m?
Like, why is that like m sub tan? You know?
Are you asking why the slope is not a tangent theta? It is for a straight line. The slope is tangent theta if it's a straight line.
No, I'm saying why isn't the denotation or the notation like an m and then under a tan?
Oh, I don't know. Well, where do you see that?
No, I'm just wondering why it isn't. If
Oh.
there's a reason that there's
I think that no. The reason for m, the letter m, it's a Greek word mantissa, means slope. You know, that's where the letter m came. But tan, if it's straight line, the slope happens to be tangent theta because the rise over the run. So maybe that's like if that's why you're asking why isn't it? So when you have a triangle, and you want to find the slope of it, isn't that the rise over the run? And this is the opposite side, and this is the adjacent side. So the slope m is the opposite over the adjacent. And if I ask you what is tangent theta now, you go, oh, tangent is the opposite over the adjacent. So when you have a straight line, the slope is really tangent theta. I don't know if that answers your questions. He wants to know why it didn't call it m tan, you know? I don't know. Maybe they have for something else.
That's what I was wondering.
And the last one, 17. Oh, we have a rocket taking off here. Television camera at ground. Here we go. Number 17. Here's a rocket taking off. We have a camera here watching that spaceship take off. I'm looking at the picture, just writing the picture for now. Theta. 750 meters away from it. That doesn't change, stationary. We're not sure what the height here, h. I was trying to read what it says that I couldn't tell first, but that's h. A television camera at ground level is filming the liftoff of a space shuttle at a point 750 meters from the launch pad, right here. Let theta be the angle of elevation. Angle of elevation when you're looking up, angle of depression when you're looking down, for those people not sure. And let S be the distance between the camera and the shuttle. So this is S, from here to there. See the figure. Write theta as a function of S. For the period of time when the shuttle is moving vertically. Then differentiate the result to get d theta dt. So the first question, they want us to find theta as a function of x. There was really no mention about the height there. I put the height myself there. But when I read the problem, there was nothing about the height. They talked about S. They talked about this side. So maybe I shouldn't even label this side H. Don't even talk about it, because in the problem there was no mention about it. That's the height of it. So I don't want to bring it to my answer, since that was not mentioned in the problem. Now when you look at that, we have this side, which is what? The adjacent, and we have that side, which is the hypotenuse. So we know cosine theta, it's the adjacent, which is what? 750 over the hypotenuse, which is S. Well, they don't want us to solve for cosine theta. They want us to solve for theta. So how do you get rid of the cosine? Arc cosine, because that's the inverse. If you have a trig function like cosine, the only way to get rid of it is by taking the arc cosine. So these two will cancel each other out because they are the inverse of each other. And theta is equal to the arc cosine of 750 over S. So now I'm going to take the next question is take the derivative of that. What's d theta?
It's always one, right?
D theta dt in terms of ds dt. They want d theta dt as a function of ds dt. So they want the derivative with respect to time, not with respect to s. What'd you say, George? Right, that's 750s to the minus 1? Is that what you said? I like it. That's what you said. I like that answer. Instead of over s, how about s to the minus 1? It makes the derivative easier. So now take the derivative with respect to t. That's what they're saying. The derivative theta with respect to t is what? D theta dt. That's what they're looking for, actually. That's the answer they wanted. Now, there's a cosine, so my u here is going to be what? 750 s to the minus 1. And what's the derivative of that? Negative 750 s to what power? Negative 2 times the derivative s, which is ds dt, because we've taken the derivative with respect to dt, not with respect to s. They want it with respect to dt. If you look at your units, they said write the answer, and they have ds dt on the right side, and they have d theta dt on the left side. So they've taken the derivative with respect to that. Using the equation for the cosine, which is minus u sub prime over the square root of 1 minus u squared. Plug in these values. What is u sub prime? That would make it a plus. When I clean it, it will be 750 over s squared ds dt. That's the derivative. In the bottom is going to be the square root of 1 minus, that's 750 over s and square it. I'm not sure actually how far they want us to go with it, because that'll be 750 when you have a fraction divided by another one. You can move that s squared to the bottom. Take a 750 and square it. That's 750 squared over s squared. I'll play more with this. A couple more steps. If you look just inside this one, under the square root, what's the LCD? S squared. This will be S squared minus 750 squared divided by S squared. Now, when you break the square root, that'll be the square root of S squared minus 750 squared divided by what? What's the square root of S squared? S. That cancels one of those S's, and I will stop right there. And I don't know how far they want to go with it. Me, I will stop right there. That looks clean enough for me. And don't forget to write dsdt. I love the dsdt here. They don't have to type that because they put that at the end of the box for you. But here we don't have any boxes. The only thing I'm looking at the book actually, at the solution, they wrote the same thing except the square root, they wrote the power of what? 1/2. They have the same thing except they put 1/2 here. Instead it's the square root. Because the square root means the power of 1/2. So they put parentheses, they wrote 1/2 instead of a square root. But it's the same exact answer. So we did it right.